Record. Sorry for those of you that weren't here yesterday and got a terrible recording. Did anybody watch that video that wasn't here? Sorry. Okay, here's a scoop. 7-2b. Psst. You are going to be multiplying powers that have the same base, which we've done. If they have the same base, we were adding them together, right? But now we're going to bring some fractions into the mix. And I know you love fractions, right? So the first thing I need you to see, okay, a fractional exponent. Really what happens is we're taking a root of some sort, a square root, a cube root, a fourth root. The fraction is doing that same thing. So you need to pay attention to what the number is to figure that out. Here's how it goes. When you have a fraction, okay, like x to the 1/2 power. When you think of a power, right? So think of someone in power, the president of the United States. He's at the top, right? The superintendent, he's at the top of the school system. The coach, he's at the top. He's a person in power, okay? The power is always on top, okay? So look here, that is x to the first power. The bottom number, okay, is the root. Think roots go down into the ground, okay? So that bottom number is our root. Are we done yet? Be done. Pay attention. We're going to get this, okay? Okay. Hello, Miss Gilly. Thank you. Okay, so the root, that's the thing that goes down. We're going down with our root, right? The root. So it's the one that is on the bottom, okay? So think root, the bottom number, power, the top number. We're going to turn that into a radical scenario. So x to the 1/2 power, we take that 1, that's my power. We take that 2, that's my root. So that is the square root of x to the first power. Those are the exact same thing. They are written in a different form. One's written in exponential form, one's written in radical form, but they mean the exact same thing, okay? So just keep in mind your numerator is your exponent, your denominator is your root. So if I said 9 to the 1/2 power, I'm saying 9 to the first power, but I'm taking the square root of that, okay? Basically what you're asking yourself then is what times itself twice equals 9, right? What is the square root of 9? 9 to the 1/2 power is what times itself twice. So what would 9 to the 1/2 power equal? It's 3. 9 to the 1/2 power is 3. It is the square root of 9, okay? All right, so here's what we're going to do with this. This is 81 to the 1/4 power. There's lots of excited laughter going on there. Could you rewrite that in radical form? What number would go there? Is that the 1 or the 4? It's the 4. It's your root, right? It's that number on the bottom that goes here. So this is a fourth root of 81. 81 to what power? The first power, right? So this is a fourth root of 81, which means the question you should be asking yourself is what can I multiply by itself 4 times to get 81? So what times itself times itself times itself is 81? It's 3. Can I show you how you plug that into your calculator? Okay, let's try this. On your calculator, you're going to type in 4 to make it a fourth root. You're going to type in the second button. And then it's going to be, is it this button on your calculator too, or is that just my button?
Is it 3?
Oh no, it's the caret. Sorry, ignore me. Well, don't ignore me, but don't do that. Okay, so 4 second caret, and then type in 81 and hit enter. Did you plug that in? Plug that in. I don't care if you think you know how to plug it in already. Plug it into your calculator right now. plug it into your calculator. Okay? The fourth root of 81 is what? 3. Okay? So 81 to the 1/4 power is 3. What times itself 4 times gets you 81? That is 3. Okay? Okay. I don't want you to rely solely on your calculator for these. Some of these you should know off the top of your head just because you can think through it because they're smaller numbers. So don't plug this one into your calculator right now. I want to see if you can get there. If you were going to write this as a radical, where does the 4 go? Is that the number here or the number here? The root, right? It's this one, the 4th root of 16 to the 1st power. Well, 16 to the 1st power is 16. So the question you should be asking yourself is what times itself, itself 4 times is 16. Anyone know what times itself 4 times gets you 16?
4.
Not 4, 2, right? 2 times 2 times 2 times 2. That's 4 times itself twice. 4, we want it 4 times. What number times itself 4 times? So 2 times 2 times 2 times 2 is 16. Okay? So the answer to this is the number 2. 16 to the 1/4 power equals 2. Does that make sense? Okay, so then look at this one. 27 to the 1/3 power is saying what times itself 3 times. If you were going to rewrite this in radical form, would this be a square root, a cube root, a 4th root? What would it be? Remember, your root is the bottom number. It's a cube root, right? The cube root of 27 to the 1st power. What is the cube root of 27? 3. What times itself 3 times gets you 27? That's 3. Okay, so 27 to the 1/3 power is 3. You with me, gentlemen? Got that? Okay, so then how do you rewrite this one in radical form? What type of root are we using? Square root, cube root, 4th root? Square root. This is a 2, right? So the square root of 64, what is the square root of 64? 8. So whenever you see something to the 1/2 power, you're just thinking take the square root of it. Anything to the 1/2 power is the square root of that number. So what would be 121 to the 1/2 power? 11. What times itself equals 121? That's 11. Yes, ma'am.
Can you go back to
To A? Mm-hmm. Okay, so then it will happen at times that your numerator won't be a 1. So all of these, your numerator was a 1, right? You had 1, 1, 1, 1, right? That didn't change much because it was 27 to the 1st, 64 to the 1st. Anything to the first power is that thing. Well, now our numerator is going to change a little bit. It's the same setup. Your numerator is the exponent, so it's something to the 3rd power. Your denominator is the root. So the 2 is the square root. If it's a 3 on bottom, it's a cube root. If it's a 4 on bottom, it's a 4th root, okay? The difference now is you're going to be taking something to a power. Now, the rule is you can actually do this in either direction. You can do either one first, but there's definitely one that is a little bit nicer. So here's what I would do with this, okay? This is a root, which means it's what kind of root? Square root, cube root, 4th root? It's a square root. When it's a 2, that's a square root. This is easiest to say the square root of 9, which is what? The square root of 9 is 3, okay? And then attach your power. 3 to the 3rd is 27. 3 times 3 times 3 is 27, okay? So what we're doing is square rooting and then cubing. Now, you don't have to do it that way. You could cube first and then square root, but you get huge numbers if you do it that way. So I don't recommend it. I always recommend do the root first and then take the exponent, okay, which is what I did here. Okay, what times itself gives you? 9, that's 3. Take that and cube that number. Okay, so in this setup, 64 to the 3/2 power, what root are you taking? The square root, right? You're going to go the square root of 64 takes care of the 2, which is what? 8. Okay, what are you doing to that 8 to solve this? Cubing it. 8 to the 3rd power. Now, I don't need you to know what 8 to the 3rd power is. Just type that into your calculator. 8 to the 3rd power.
Wait, can't you just plug it in to calculator and then problem?
Are we going to? No. But yes, you can. Okay, so that's 512. Olivia makes a good point that I was just going to brush over and not tell you about, but you can plug these into your calculator as the fraction. Here's the issue. I want to know that you understand what's happening, so you still need to show me what you're doing. You need to show me you took the square root of 64, and then you need to show me that you cubed that. Then you may plug it into your calculator, and that's fine. But if you don't show me any work with it, I won't give you full credit for it, because I don't care that your calculator can calculate it. I want to know that you understand the process, right? So just make sure you show me what you're doing. Okay, take a look at this one. What are you going to do first? The square root, right? This is your root. The square root of 25, which is what?
5.
That's 5. And then what are you doing to the 5? You're cubing it. 5 cubed is 125. So like that one you can do without your calculator, right? You probably all know 5 cubed. You probably all know the square root of 25. Show me what you got. If then you want to just plug into your calculator 25 to the 3 divided by 2, right? This will give you the final answer. You may do that to check it. I just don't want that to be your first step, okay? I want to see how you got there. Okay, so 27 to the 2/3 power. What are you going to do first? You're going to cube root 27, right? 3rd root of 27. What does that equal? What times itself 3 times gives you 27?
3.
That's 3. Okay, then you can take your power. So 3 to the 2nd power is 9. So 27 to the 2/3 power is equal to 9. Does that make sense? So it's a 2-step process. You're going to take the root, and then once you've taken the root, then you're going to take it to the power. Okay? Okay. Last one of these guys. 16 to the 3/4. What do you do first? Not square root. 4th root, right? The 4th root of what? 16. 4th root is 16. What is the 4th root of 16? What times itself 4 times is 16? 2. Then you do what? Take it to the 3rd power. You cube it. So 2 to the 3rd power is 8, and you're done. How are we doing with that? Does that make sense? So. Just make sure you start with the bottom. This is your root, so take the 4th root. Then that should be your first step. Your second step is take it, whatever you get there, to the power, which is this guy. So take the root, then take the power. Okay? Any questions on that? Cannot believe how much rain is coming our way. What? Okay. Next thing, we're actually gonna skip this one because I think I messed up in how I wrote it. And we're just gonna skip it because we've got plenty other ones to do. So go to letter B. I think, you know what, you try it. You know all the concepts of this right now. We're not gonna worry about turning our fraction into an actual number because it's a C that we're taking to that fraction. So you may have a fraction in your answer right now, okay? Simplify that and see what you get. Do you have an answer for me or a question? Yeah.
Are we just putting it in like the root then?
You're not doing roots here. So you're just gonna simplify this as you see it. Yeah. Just try to simplify how you would simplify. There are a couple ways you could go here. I'll show you which one I want you to actually land on. Okay, who has an answer for me? There's two parts to this. There's a number and there's a variable. Anyone know the number? It's a 4. You're going 2 times 2 is 4. Okay, how do you simplify c to the 3/5 times c to the 1/5? You add the fractions. When they have the same base, c and c, you're adding those exponents together. So this is c to the 3/5 plus 1/5. What is 3/5 plus 1/5? 4/5. So c to the 4/5. So your answer is 4c to the 4/5 power. If we were to change that up and put it into a radical form, this would be the only thing that you change, right? The 4 is not attached to the 4/5. You're not taking 4 to the 4/5 power. So because we can't do that well, it would just be a variable still. We don't take it to the 4/5 power and try to turn it into the other form. So that would just be your answer. Okay. Go over to C. N to the 1/3 times n to the 4/3. What are you going to do? You're going to add the fractions. What is 1/3 plus 4/3? 5/3, right? You don't add your denominator, add your numerator. So n to the 5/3, and that's as simple as you can go. Technically, if I asked you to turn it into radical form, could you do that? If I asked you to turn this into radical form, it would be what? What's your root? A third root. So it'd be the cube root of what? N to the 5th. So you could write it like this. This would be radical form. But this is all I'm looking for right now. Just simplify it and leave it in exponential form is what we call it. Okay? Where's my D? There's my D. Okay, what do you do here? You what? Find a common denominator. With which fractions? Right, separate them. B, C, okay? So you have B to the 2/3. I'm just gonna rearrange this. You don't have to rewrite this, but I'm gonna put the B's together and I'm gonna put the C's together. Properties of multiplication tell us we can multiply in any order and it doesn't change our answer, right? And this is all multiplication, so this is fine. We can rearrange. It'll be C to the 2/5 times C to the 9/10. Now find a common denominator. What's my common denominator going to be for my B's? The common denominator, the bottom number. It's 9. This one is 4/9. So to turn this into ninths, we would multiply by 3/3. So this is B to the 6/9 times B to the 4/9. What is that? Stop throwing things at each other, gentlemen. This is b to the 10/9. Okay, so that's your b taken care of. What's your common denominator for the c's? It's going to be 10. So make this times 2 over 2. So c to the 4/10 times c to the 9/10 is what? 13/10. Is there anything that you can simplify there? Khalees, what's up?
When I put the equation into my calculator,
Say that again.
when I put the fractions for the into my calculator, I got 10 minutes. So doing this is so different.
Oh, you're just putting it in the fraction plus the fraction. Yeah, your calculator's doing it for you. That's okay. So b to the 10/9 times c to the 13/10, and that's your answer. Okay, you don't have to simplify anything further. You're just done there. Questions on that? Okay, last one. Talk me through this. What are you gonna do first?
You could just like put it together, or like there are 3 J's.
Okay, if we
Separate.
split this, if we separate this into the things that can actually get multiplied, how many different groupings are we gonna have?
A lot.
3. Why 3? The numbers, yes, okay. I cannot emphasize enough that those numbers are being multiplied by the variables, just like the variables are being multiplied by the variables. But for some reason, people always think this 3 has to stay with that j. It doesn't. If I rewrote this, this is 3 times j to the 2/3 times 7 times m to the 1/4, right? That's the same thing. This is the same thing as this. So if it helps you to see it separated, put a dot in between all of them. That's fine. Because we're not adding or subtracting anything. It's all multiplication.
So you multiply.
So the rule is you may multiply every single number. So you have a 7, a 3, a 7, and a 3. You can multiply all of them. So go 3 times 7 times 3 times 7 is 441. So that takes care of the numbers. Okay, then if you want to put your J's together and your M's together, you can do that. I'm going to get rid of that here. So this is J to the 2/3 times J to the 1/6 times M to the 1/4 times M to the 3/2. How do you multiply this? What is J to the 2/3 times J to the 1/6? Multiply by 2 over 2 to make it J to the 4/6 times J to the 1/6. What do you do with that? Add those together. So this is J to the 5/6. So far we have 441, J to the 5/6. Now look at your M's. What's your common denominator? It's going to be 4, so multiply by 2 over 2. So this is M to the 1/4 times M to the 6/4 is M to the 7/4. Okay, so it's just a lot of pieces. Take your time and do those pieces well. Do the numbers as one thing, do the J's as one thing, do the M's as one thing. Okay? Any questions on that?